4 is about algebraic reasoning. Good news is this is really easy until the very end when you start the first steps towards proofs. But that's okay, you love this. This is stuff you've done before, working with the algebraic properties of equality. Difference is that before you just solved the equations and didn't think twice about it. Now you gotta solve the equations and defend your answer. Each step, you gotta justify it. So those of you who like to do things in your head are gonna hate this part. So when you solve equations, as you already know, we use properties. We add, subtract, we distribute, things like that. So since segment length and angle measures are real numbers, we can also use these rules in regards to them in geometry. So these are properties here you should already know. Adding says if I add a number to one side of the equation, I've got to add it to the other side. Same as subtracting, same as multiplying, same as dividing. Substitution property says if A equals B, then A can be substituted for B or B for A in an equation or expression. And the associative property, of course, we did that a lot in algebra. You can take the outside number and multiply it by everything on the inside. So here's what I mean by justifying steps. There's nothing new in this unit, well, this part of the lesson, I should say, that you've not done before except for the justifying part. So here we have an equation. Explanation is write the equation. The reason is called given. In geometry, when you are given information and you write proofs, which we're starting to write proofs now, your first step is always the givens. You list what you were told. You call that given. So now your first step would be to add the 4x to each side, and that's the addition property of equality, and it looks like that. Then we would simplify by combining like terms. And we'd have 7x plus 2 equals 23. So the equation part that's nothing. This part over here is going to drive you crazy. You have to explain everything you did and tell me the reason why you're able to do it. Now we're going to subtract that 2. We're going to simplify it again by combining the constant terms, or still like terms, but whatever. Then we're going to divide by 7 and get x equals 3. These are the things I have to see, the reasons. The words to steps are not necessary. It's what you're doing, but the reasons. How do you know you can do this? What do you know you can do? Well, simplifying lets you do these things. You have to justify each step. So I tell you to solve an equation and justify each step. If you don't give me the reasons for each step, guess what? You get the problem wrong. Even if the equation's correct, your answer is going to be wrong if you didn't justify it. Of course, you should always check your answers just to make sure things work out. So same idea. Your given is the equation. Now you're going to distribute. And you get negative 35w minus 40 equals 30. Now I'm going to use the addition property of equality. We're going to add 40 to each side. And then we're going to divide and get w equals negative 2. All right, so a word problem here. You guys love these things. You get a raise at your part-time job. To write your raise as a percent, use the formula p parentheses r plus 1 equals n, where p is your previous wage, r is the percent increase, written as a decimal, and n is your new wage. So you want to solve the formula for r, and then what is your raise written as a percent when your hourly wage increases from $15.25 an hour to $15.86 an hour. Step 1, you want to get the r by itself. So as you're given, we're going to distribute, get PR plus P equals N. We're going to subtract P from each side. Then we're going to divide by p and get r equals n minus p over p. So now I want to evaluate. Remember they said here, p is your previous wage, so 1525, and n is your new wage, so 1586. Just going to plug all those in. You get 0.04. Now that's a decimal. They said as a percentage, so you're going to change that to 4%. So again, the math part of this, you did in Algebra 1. It's the reasons over here that you're looking for. So there's other properties of equality. Again, you have these in that packet I gave you. First one is a very common sense one. It's called the reflexive property. It says that A equals A. In other words, a number equals itself. In geometry, the segment length AB equals AB, or the angle measurements, measure of angle A equals measure of angle A. It's kind of common sense. It equals itself. That's what reflexive property is. Symmetric property is similar, but a smidgen different. It says if A equals B, then B equals A. It's like flip-flopping, basically. So if you have segment AB is equal to segment CD, then CD equals AB. If measure of angle A equals measure of angle B, then measure of angle B equals measure of angle A. I know these are all obvious. A lot of geometry, a lot of proofs in geometry are just stating the obvious to the point where it kind of physically hurts your soul to do so. And of course, the famous transitive property, if A equals B and B equals C, then A equals C. And that works again with segments and angles. So we're going to return to this little example here in our next lesson, so you're going to recognize this sum. So they're saying you're reflecting the beam of a spotlight off a mirror lying flat on the stage. So they want you to determine whether angle DBA is congruent to angle EBC. And we're going to be writing a little 3-column thing here. So our given is what's marked in the diagrams. They mark that angle 1 and angle 3 are congruent. So we would write measure of angle 1 equals measure of angle 3, because we already had that. Now, using the angle addition postulate, we can say the angle DBA, which is right there, equals the measure of angle 3 plus the measure of angle 2, which is how you get the bigger angle. And that's the angle addition postulate. Now we're going to substitute here. Since the first step said measure of angle 1 equals measure of angle 3, in this step down here, I can now replace measure of angle 3 for measure of angle 1, because they're the same angle. And the rest will stay the same. Now again, we're going to do an angle addition postulate, and we're going to add the measurements. So the measure of angle 1 plus the measure of angle 2 is the measure of angle EBC. So now we have our transitive property. Since measure of angle DBA equals measure of angle 1 plus measure of angle 2, and since the measure of angle EBC also equals the measure of angle 1 plus the measure of angle 2, we can state that the measure of angle DBA equals the measure of angle EBC. This is your first taste of a proof. You can see more of them in the next lesson, and more and more after that. But it kind of goes like this. And the problem is that you got to figure out what steps to take. They don't usually guide you. They do it first, but after that, you're on your own. You got to figure out all the logical steps to go to prove what you need to prove. Okay, another word problem. I know you're so happy. Calm down. So you have a park, a shoe store, a pizza shop, and a movie theater are located in that order on a city street. The distance from the park to the shoe store is the same as the distance from the pizza shop to the movie theater. You have to show that the distance from the park to the pizza shop is the same as the distance from the shoe store to the movie theater. At this point, you're going, what? Welcome to geometry. I told you it'd be harder than algebra. So what we're going to do first, we're going to draw a diagram. So there's our city street. We got a park, shoe store, a pizza shop, and a movie theater. Now we know um, what we can do is simplify by just using letters instead of words. So P, S, they use Z for pizza. It doesn't matter what you use. M for movie theater. It's just easier to do diagrams with single letters than words. Do you have to use the letters? No. You can keep the words if you want to. It doesn't matter. But it's just easier to use the letters. All right, and they told us that the park to shoe store is the same as the distance from the pizza shop to movie theater. So we mark the park and shoe store distance and the pizza movie theater distance as congruent. A little red marking there. So now we know that segment PS and segment ZM are the same length. That's what we were told. That's what we were given. What we're trying to figure out here is the distance from the park to pizza shop. So that's from P to Z, that segment right there. And then we'll see if it's the same as shoe store to movie theater. So you have to show that PZ equals SM. So we already know that PS equals ZM. That's marked in the diagram. That's our given. So let's do some segment addition. So we're going to add length of adjacent segments. So PZ, this piece right here, is PS plus SZ. That's an easy one, right? We're going to do it again for the other one. So SM, this bigger piece over here, equals SZ plus ZM. So we're going to add SZ to each side of our first equation, PS equals ZM. Because remember, these are numbers, these are distances, so we can do that. It's like solving an equation. Now, since we have the other equations here, we're going to substitute PZ for the left-hand side and substitute SM for the right-hand side because that's what they already are.